Hello, and welcome to AIEM's Introduction to Microsoft Project 2003 video sessions. This is the 7th video in the series and introduces critical path. With the Gantt chart formatted and showing critical path from the last session, it is important to understand exactly what critical path is and why it is useful to you. By definition, critical path is the longest series of tasks through the project where the change in duration or start date of any of the tasks on the path will change the overall duration of the project. In our example, if like Design User Interface or Program Module A changed in duration or start date, the overall duration of 28 days for the project would be changed. The tasks in red are critical tasks, and the tasks in blue are non-critical. This means that they have some room to change duration or dates without affecting the overall duration of the project. The amount that they can change is called slack. The red tasks have zero slack, and the blue tasks have some slack. You can view the amount of slack available to any task by Main Menu, View, Table, Schedule, and adjust the view to expose the columns. Note that the red tasks all have zero free slack. The task Assemble Hardware has a free slack of 2 days. This means the task can take 2 days longer than expected, or take the same amount of time but start 2 days later, and still not affect the overall duration of the project, or in other words, the critical path. Once you have your critical path, it's important to assess its likelihood to change. This is called sensitivity analysis. A high sensitivity means it has a high probability of change. A low sensitivity means a low probability of change. There are several tests to determine a critical path sensitivity. First, are most tasks for the project on the critical path? If they are, there is a high probability that not all the tasks will be completed on time, and therefore a high probability that the critical path will change. High sensitivity. Is there more than one path to the critical path on the project? In our case there is not, but if there were, there would be a higher probability that one or more tasks on one or more of these paths would not complete on time, and therefore affect the critical path. High sensitivity. How much slack is available for non-critical tasks? The lower the ratio of slack to overall duration of the task, the higher the probability that the task will not complete on time. For example, in Assemble Hardware, we have 2 days of slack for a task which we estimated will take 2 days to complete. This means that it can start 2 days late and still complete without affecting the critical path, or it can start on time and take twice as long as we had estimated and still not affect the critical path. This means that it has a high probability of completing within the slack, and therefore low sensitivity. If we had a task with a duration of 40 days and only had 1 day of free slack, then there is a higher probability that the task will not complete within the slack, and therefore higher sensitivity. Our project has a high sensitivity given the high percentage of tasks which are on the critical path. In doing this analysis, you not only have a critical path, but you have an analytical understanding of its likelihood to change, and can discuss this with your sponsors and team members. This ends the Introduction to Microsoft Project 2003 Critical Path. The next session will involve tracking and variance. Thank you.